So guys, as you can see, this is our temperature which is being calculated by this DHT11 sensor. It is falling and humidity is rising. We just warmed up the sensor, see that. Now let me show you the code, how it is, what is happening here. We are using the same code from the previous video and we just modified that. Instead of going for the HC05 Bluetooth module, now we are using the LCD. See, I am displaying the data on the LCD using these commands, and then I am displaying here it is the temperature and here it is the humidity. So we are only displaying the integral part. So as you can see on the sensor, we are only getting the integral part, not the decimal part, because this sensor is not very accurate anyhow. See that? So it is working perfectly fine. Hello guys, welcome to learning microcontrollers. In this video, I will show you how you can interface a PIC16F877A microcontroller with a DHT11 temperature and humidity sensor, and then we will display the output on a 16x2 LM016 LCD. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version, and this over here is a DHT11 sensor module. I am using a module, it has 3 pins, but if you directly use this sensor, it has 4 pins. One pin is not connected and you will use a 5.1 kilo ohm resistor between signal and the power pin. Like you will connect a pull-up resistor of 5 kilo ohm value between the signal and the power pin, that's all. Then it will become a module. But if you use a module, then you have an onboard resistor, you do not need a 5 kilo ohm resistor at all. Now guys, this is labeled like this, where there is S, there is signal, this is the signal pin, then we have 5 volt and then we have ground pin. The voltage can be minimum 3.3 and maximum 5.5 volt. Now guys, let's connect it. For the signal pin, you can use any available digital input output pin of the PIC. I am going to use the pin number D0, that is pin number 19 of the PIC. For 5 volt connected to the VCC of the PIC, ground connected to the ground of the PIC. Now guys, to display the output, we will be using this 16x2 LM016 LCD. As you can see, this LCD has 16 pins. Now to connect this LCD with the PIC, we will need a 3-pin potentiometer to adjust the contrast of the LCD. It also has 3 pins, and on the body it's mentioned 1, 2 and 3, and it's a 10 kilo ohm value. Now let's connect it. First of all, as you can see on the body of this potentiometer, you have 3 pins labeling 1, 2 and 3. Label it like this. Now guys, for the LCD, if you hold it like this, from left to right it is 1 to 16 like this. Now guys, let's connect it. You common the pin number 1 and 5 of the LCD like this. Then you connect it to the pin number 1 of the potentiometer. From there you send it to the common ground like this. In this way your LCD and the potentiometer gets grounded. Now guys, pin number 3 of the LCD is the adjustable contrast pin. You connect it to the pin number 2 of the potentiometer to adjust the contrast. Or if you have a different potentiometer, then adjustable pin will go to the pin number 3 of the LCD. This will help you to adjust the contrast of the LCD using this potentiometer. Now guys, pin number 2 of the LCD is the power pin. You connect it to the pin number 3 of the potentiometer, then you send it to the VCC of the PIC like this. In this way, your potentiometer gets the 5 volt and your LCD gets the 5 volt. Now guys, pin number 4 of the LCD is the RS pin. You can connect it to any available digital input output pin of the PIC. I am going to use a pin number C0 like this. For pin number 6, that is the enable pin, again use any digital input output pin. I am going to use the pin number C1 like this. Now guys, for the pin number 11 of the LCD, that is data pin 4, I am going to use a pin number C2 of the PIC. Pin number 12, I will connect it to the pin number D2 of the PIC. For the pin number 13, that is data pin 6, I will connect it to the pin number D3 of the PIC. And for the pin number 14 of the LCD, that is data pin 7, I will connect it to pin number C4 of the PIC like this. Now this pin number 15 and 16 of the LCD, they are for the backlight. If your LCD have backlight, only then you will connect these 2 pins, else you will not connect these 2 pins at all. You will leave them floating. Now this LCD that I have do have a backlight, so pin number 15 is the 5 volt for the backlight and pin number 16 is the ground for the backlight like this. Just connect it to the common ground of the PIC like this. Now guys, these 4 pins, pin number 7, 8, 9 and 10, you will leave them floating because we are using the LCD in the 4-bit mode. They are used if you use the LCD in the 8-bit mode. Now guys, this was the total connection. Let me introduce you to the hardware before we move on to the programming. See that this is guys our DHT11 sensor over here. This is the LCD and behind it is our hardware PIC16F877A, and the wiring is as shown in the presentation. So let's get to the MikroC. So guys, this is our MikroC for PIC. Let me zoom in so you guys can see better. Now this is version 7.2.0. You can use the higher versions as well. Higher is always better. Click on File, New Project. Okay, this window pops up, New Project Wizard. Click on Next. Write the name of the project. I write DHT11 LCD tutorial by learning microcontrollers, like this. Now guys, this is the path where your codes will be stored, and now this is the microcontroller you are going to use. Select the device name, and I'm going to use the PIC16F877A like this, and this is the crystal connected to the pin number 13 and 14 of the PIC. I have a 20 megahertz crystal over there, so I will write 20 megahertz here. Click on Next and Finish. So guys, this window pops up. Before you do anything else, first of all, save your work. Press Ctrl S and save your work. Now guys, we will fetch the code from my previous video on DHT11, in which I had shown you in very detail how to use this sensor. So we will simply use that code. So just go to my channel. In my channel, look for this video. I will also share the link to this video in the description. See that this is the video, and in the description of this video you can see. Just go to the description. I will share this link, okay? Don't worry about this. This link will be in the description of the video. So just go to the description. Here you have this thing over here. This Google Drive link to MikroC for PIC files. This. Copy this link or just open it in a new window, and this will lead you to this window. Here you have those codes. Now you simply download this code. See, this code is over here. Just download the whole code. Click on Download. Okay, wait, let it download. We will simply use this code because it has great details in it. You can learn from this code. I will simply modify this code. In that we were using a Bluetooth, but in this code we will be using an LCD, while the rest of it will remain the same. Simply click on download. Okay, it is showing something, zipping, preparing to download. Just wait. Okay, it is downloading. Okay, it's downloaded. Just go to the folder where you have downloaded this file, copy it, bring it to some other folder where you will store it. I simply bring it to this folder. Okay, just paste it. Now you have pasted it, extract it, right click on it, extract wherever you want, and these files pop up. Here you have this C file. You double click on the C file. Okay, there you go. Or you can even do open it in your MikroC as well. Okay, I show you how to do that as well. Just go to your MikroC, click on File, Open. Now, once you click on File, Open, go to the folder where you have extracted that file. I had extracted it over here. See, when you will go to this folder, automatically this file will show up because it's a C file. You just click on Open. It will open in your MikroC. See, this file has just opened up. Now guys, we have this code over here. So we will integrate this code into our this new window. Okay, we will integrate this code here. So this is the code we downloaded from my previous video. You just copy. Okay, you just copy it. First of all, copy all the variables like this. Go back, paste it above the void main like this. Like this. Then guys, go back again. Now copy the functions that we had in the video. To learn how I made this, you can go back to that video and you can learn from there. I will simply implement that code in this video. Now we have our functions. Now go back to the video again. Now copy what is in the void main one time loop. You copy it over here like this, and you delete the UART INT 9600 because we are not going to use the Bluetooth module here. We will be using an LCD. Now instead of this, go to the right. We initialize LCD because we are going to use LCD here. Expand this MikroE libraries, system libraries, check mark the LCD. We are going to use the conversion library, check mark the conversion library, and then that's it. Now expand the LCD library, double click on this LCD I90 command. This will lead you to this window. Here in the example, you copy these files from here, copy it till here, don't go below this. Go back, place it above the pasted variables like this. Now guys, here you will define your pins that we have just used for the LCD. For RS, we are using pin C0, 0 for RS, and for EN we are using C1. So just make it C1. For D7, data pin 7, we are using C4. Make it C4. For data pin 6, we are using D3. Make it D3 over here. For data pin 5, we are using D2. Make it D2 over here. And for data pin 4, we are using C2. So these are the pin configuration. Recheck C0, C1, C4, D3, D2, C2. Now again do the same for the pin directions. For the RS, it's C0 exactly same as above. C0 for the EN, it is C1. For data pin 7, it is C4. For data pin 6, it is D3. For data pin 5, it is D2. For data pin 4, it is C2, like this. See that? In this way, our LCD is initialized. Now go down. Here we already have our variables copied. Now go to the void main below this here. Go to the right in the LCD. Double click on this LCD init command again. From below this, you have this command LCD init. Copy this. This will initialize the LCD. Like this. Now the LCD is initialized. Give some initialization delay for the LCD. 100 will do fine. 100 milliseconds. This delay is not necessary, but I always suggest to give it in the one-time loop. Now guys, we turn off the cursor. There is a cursor on the LCD by default. I don't like that cursor. If you like it, you can keep it. That cursor do have a use, but it's about likeness. So this command LCD CMD, double click on it. This will lead you to this window. Copy this command from the example LCD CMD LCD clear. This command clears the screen. Just copy it in the void main where you initialize LCD like this. Remove whatever is in the brackets like this. Go back to the same command LCD CMD. Double click on it. And here in the available LCD command list, look for the command turn off cursor, this command. Copy the part in the green, that is the command, and paste it in the bracket here like this. Now this command will turn off the cursor, give some initialization delay. Just 10 will do fine. And it is also not necessary. If you don't want to give, you may not give. It will still work fine. Now we clear the LCD for one-time loop. Like whenever the system starts, the LCD must be cleared once if there are any rank back values. Just copy this command LCD CMD LCD clear, paste it below this like this. Now the LCD is cleared. Now we go for our forever loop. Write down while 1. Forever loop starts here, ends here. Now guys, remove this space. Make it look presentable. Go back to the code we just downloaded from my previous video. Go to the while 1. Copy everything in the while 1. Copy it here, till here. Now here the while loop ends. Now go back to the new code we are writing. We integrate this into it like this. Now here we are using the HC05 module. Rest is fine. Our functions are initialized. Our data is being taken. We will only display the integral part of humidity and integral part of the temperature. That's fine. And checksum is same. Okay, these commands we need to change. Now go to the LCD library. Instead of using HC05, now we are using the LCD. Copy this command LCD out, this command over here. Go back, paste it over here. Now copy this temp. Now we will display it on the LCD instead of on the HC05. So paste it here. Temp equals to, now delete this. We have just, now we should start writing this from the first row, first column. Temperature equals to, now how many digits are there? We only have 16 digits on one row. So we'll start writing from the first row, first column. 1, 2, 3, 4, 5, 6. 6 digits are gone. So this means that we can start writing from like 8th digit. So we give a space, like it will be 7. So now we start writing from the 8th digit. What we should write? The temperature. Just after 8 digit, start writing the temperature, make it 8, and whatever the temperature is will be written after the 8 digit like this. Just copy this variable over there and delete this command too. And this degree centigrade now we display it at the end. Just paste this again, and instead of temperature at 115, that is first row 15th column, display C over here like this, type C like this. Now temperature will be displayed on the first row. Now on the second row we display our humidity Now for the temperature as well, once it's displayed, we should keep it on the screen for some time, delay MS200, because this sensor is slow. It takes like 2 seconds to update a new value. So you should make use of that time to rectify your data on the LCD. So now this is for the temperature. Now we do it for the humidity. Copy these 3 commands, paste it below this like this, and now simply do the required changing. Humidity, just paste it here. Humidity equals to, how many characters are gone? Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can start writing humidity from the 10th character. So in the next line, instead of this, you write here this variable. Now whatever is in the humidity one will be displayed on the screen like this, and start writing from the second row, first column, humidity equals to, now second row, 10th, because there are total 9 digits in it, like 1, 2, 3, 4, 5, 6, 7, 8 and 9. Whatever the humidity is being calculated by our above program, and in the end, at the second row, 15th line, we instead of showing Celsius, we show percentage, because humidity is in percentage. Again we give delay and just delete everything else like this. Now for the errors, if we get a checksum error, what we do is that we simply copy this, just copy this command, paste it here. Again inside the variable, just copy this checksum error and paste it. So whatever the error is will be displayed on the screen. LCD out, checksum error, and delete this and count the digit. They must be less than 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You also count the spaces. Now once the error is displayed, it should keep the error on the screen for like 250 milliseconds. So this will be better. Again copy this. Now for the other error, in case there is a error regarding sensor not responding, so we simply name it in a shorter form, sensor error. That's all. So in case sensor is not responding, it will show a sensor error. So after both of these commands, the LCD should clear, or we can go without clearing. It will just overwrite. Okay, that's fine. So here we go. These are for our errors: checksum error, sensor error, and this is the command. Now only changes that we made here is that instead of using the HC05, now we are going to display it on the LCD. So let's build this code and give it a try and see what happens. Okay, the code is built successfully, no errors. Let me zoom out. Okay, first go to the PIC16 programmer tool, click on file, import hex file. Okay, this is the file we just created. Click on write. Okay, the new file is being written. Let me zoom out. Okay, let it write. Let's get to the hardware. Okay, it's written. Let it write. Okay, the file is written. Let me power it up using the PIC16. Here we go. See, it is working like a charm. See that temperature, it is showing a rackback value at, I think it's 14th or 15th digit. You can deal with it, but it's fine. It's not that much. So temperature is 17 degrees centigrade. Humidity is 5. Let me bring in the heat gun. I will change the parameter using this heat gun. I give some heat to it using this heat gun, and let's see what happens. So I turn on the heat gun. I place it towards the sensor. Let it see. Heat is being transferred. See, the temperature and humidity has started to change. See that? Temperature is rising, humidity is also changing. Now guys, as you can see that temperature is working fine. We can still make this code look better. Let's go back. Let's go back to the circuit, and for the humidity, I think we are missing a character here. So we make this smaller. We just make it humi like this, and it's like because we have limited characters here, or we can just use RH equals to like this. It will do fine. Give some space. Now we have 1, 2, 3, 4, 5 characters. So we can start writing from the 6th, whatever the humidity is. Now let's give this a try. And at 15 we are doing fine. Now let's give it to the 16, and the 15th we make it blank because we are having a rackback value, as you can see. So we write from 14, give two empty spaces, 15, 14 and 15. Now they are blank. We will not get that character error that we were getting over there. So I just made 14 and 15 blank. Let's see what happens. With this LCD, this is a cheap LCD, you have to play like this to make your code look better. So the new code is being written. Let's see what happens. Let's get to the hardware. Let it write the new code. See that now it's very clear. One digit was missing and now we have dealt with it. See, it's very clear, it's perfect. So again I bring the heat gun in front. See, the temperature has risen at that time. Now I again bring the heat gun. Let me give some heat. See, temperature is again rising. See, it is going up very quickly because heat gun is set to high value. See that. So that is perfect because when the temperature rises, the humidity falls. So it is doing fine. I remove the heat gun. Now take a look here. Temperature is rising and the humidity is falling. See, still it is very warm. See, now after it gets cooled, it will start to go in the opposite direction. Temperature will fall and humidity will rise. Let's see what happens. Let it change because it is now at a constant temperature now. So I pause the code so the temperature sensor could cool down. See, now the sensor has cooled down. Temperature is falling like 56 and humidity will rise. They are like inversely proportional. See, temperature has started to fall and humidity is rising. So this is working perfectly fine. So you can play with the code. I will give you the Google Drive link to download this code as well. You can also download the previous code and play with it. You can also download this new code as well. So you will simply download and play with the code and you will learn better. If you still have any questions, you can ask me in the comment. So guys, thank you very much for your time and patience. We'll see you in the next video.